Welcome to EDU World Space.
So in this question, we're trying to find out the tension in the string when the pendulum bob is at its lowest point. So what we can use in this question is the conservation of energy. So we know that the initial gravitational potential energy is equal to the final kinetic energy. If we take the gravitational potential energy to be zero at the lowest point, we can just set this to help our calculations be easier. So the first step is to work out this change in height so that we can calculate the change in gravitational potential energy. So we know the length of the string is 0.5 meters, and we know this angle is 37 degrees. So we can work out this length here by doing 0.5 cos 37, as this is the adjacent length. So 0.5 cos 37 is equal to 0.4 meters. So this gives us this length. However, we want this length underneath. So what we need to do is subtract this from the length of the overall pendulum to find out that this is actually 0.1 meters. So what we can do now is say that 0.1 mg, which is the change in gravitational potential energy, is equal to 1/2 mv squared. Cancelling out the m's here and rearranging for v squared, we can see that v squared is equal to 0.2 g. Therefore, v squared is equal to 1.98. So what we know now is that the tension is acting upwards, and so is the centripetal force. So the tension minus the centripetal force given by mb squared over r must be equal to mg, which is just 0.1 g. So we can rearrange this further to get an expression for the tension on the left-hand side, so that the tension equals mv squared over r plus mg. And we know that m equals 0.1 kilograms, as it's 100 grams. And we know what v squared is from the previous part of the question, as well as the fact that r equals 0.5. So we can simply plug these numbers into this expression here to obtain that the tension comes to 1.376 newtons.